Hi, and how are you? Today starts a program just for you from the Salina Media Connection. People from the Salina community are getting together for a program where they'll be telling stories, dancing, singing, all kinds of fun stuff. And because it is just for you, we're calling it the Kids Connection. It's going to be on every morning at 10 a.m. Monday through Friday. It's about arts, health, wellness, and education. Like I said, lots of fun stuff you'll want to see. Again, it's on Monday through Friday at 10 a.m. The Kids Connection, just for you. Come on, join in. I know you'll have fun.
Hurtful actions and so be kind. Ooh, be kind. You can't rewind. Be kind. You can't rewind. Can't erase the things that happen in your mind, so be kind. You can't rewind. Can't erase the things that happen in your mind, so be kind.
Hi everybody, thank you for joining us for another segment of Bringing the Zoo to You. My name is Kira and I'm one of the aquarists here at Rolling Hill Zoo, and today we're going to be talking about our 500-gallon saltwater reef tank. So here we have all the fish and all the coral that we have in the tank. As you all know, coral is an actual plant, an animal, and a mineral. So what I mean by that is, what you see in coral is the tissue, and that part is consisted of polyps. That is the actual coral part of it. It also has the plant-like algae called zooxanthellae, which also gives the coral its color, and that photosynthesizes from the sunlight and to provide food for the coral as well. So during the day, the zooxanthellae will photosynthesize and create food for the coral, and at night when the light goes down, that's when the coral opens up and puts out its feeding tentacles, and then it'll filter feed through the water with the ocean currents and then just catch food from the water, and that's when the coral feeds at night. So it's actually a symbiotic relationship of coral. They're both helping each other out, both survive. The calcium, or the mineral part of coral, is calcium, and that's the skeleton of the coral. So each coral makes a different type of skeleton. Some are soft tissue coral and some are more calcium carbonate. And if you can see here, that is a Galaxia coral, and each one of those is a polyp, but that whole rock formation is actually called a colony. So right now what you're seeing is the polyps. If you were to look at just the skeleton portion of this exact coral, this is what it would look like with just the skeleton. So these are all hard pieces of the skeleton of the Galaxia, and this is calcium carbonate. And so it is hard and it's spiky, and you can see the different parts of it. And each one of these little nubs would be where the polyps would come out of the skeleton. So, and as you can see, here's the bottom of it, and like all the little tubular where it grows. And this once started as a little fragment piece just growing on a rock, and it expanded to all of this. So since we mimic ocean water, the chemistry of ocean water in a tank, we provide the different essential elements that a coral would need from the ocean, from the water. So we put in different chemicals such as magnesium, calcium carbonate, and 2 different parts of calcium chloride and sulfate, and that all helps the coral grow and just expand. This coral right here is considered a branching coral, which means it will branch off into different segments of it. So all of that is one coral, but then they each have different polyps that branch off from a singular one. As you can see, maybe with this one, this is called green star polyp. It's hard to see. This is actually an encrusting coral where it'll grow on a mat and just grow over anything that it comes into contact with. So if you are able to see some of the pink matting behind it, that's what the polyp grows off of, out of that. So it makes a little encrusting mat, and then the polyps grow from that. So that's another way that coral grow. There's a process called fragmenting on coral, and that's cutting a piece off of the coral and either gluing it or rubber banding it to a rock, and that will create a whole nother coral. So that's what a lot of aquariums out right now are doing to prevent the extinction of coral all over the world. So that's what this little piece is right here. It's a fragment of a piece that we cut off from the larger mother colony, and then it'll just grow like that. These are our anemones. They're similar, but they're only an animal. So these guys will actually eat only meaty food. So what we feed them here is fish, shrimp, just any type of shellfish or just any type of fish pieces. And they actually have a mouth in the center. And it'll use the tentacles to grab onto the food and then bring it to the middle of its mouth. And so usually on the tentacles, they have a stinging cells. But the reason why they're not stinging all the other anemones around it is because they have all split from one anemone. So technically they recognize each other because they're the same, but they did a process what they call asexual reproduction. So they just split off from one another, and then they can populate that way. Since the ocean is so vast, it's hard to find another anemone or coral that's close enough to each other. So they just split off and reproduce that way. Another way that coral also reproduce is sexually. So there are female and male types of coral. You don't really know until they actually spawn, and they do spawn eggs and sperm, and they'll just bubble up to the center or the tip of the coral, and then they'll just float to the surface of the water, and then they'll just try to mix there and then combine, and then just like everything else, they'll sink to the bottom, attach to something, and then slowly just grow from there. It's very interesting just the way coral grows and just splits. When I first started here 5 years ago, all of these corals were really small, and it's just been a real fun process just watching them grow and get so big and be able to propagate them and frag them and just really spread the knowledge of our coral. So if you guys have any comments, feel free to comment below in the section, and we'll get back to you with all your answers. Thank you for watching.
Okay, so the next thing we're going to do, it's called some clay spindles. As you see, I've got a cork with some shish kebab sticks with a toothpick in the middle, and we've got these clay balls.
You can use whatever clay you have. It doesn't have to be colorful.
I'm going to give you that one.
Okay, we bought the clay at Hobby Lobby because they have the best clay, in my opinion. But you can buy it wherever you think there's clay.
And then Rosie, I'll go ahead and get yours started, okay?
So, watch Ashley
You just-
as she gets it ready. So she takes the sharp side and she puts it in the cork.
And you're going to want it to be somewhat symmetrical
Yes.
for balance.
Yes.
So after you have that step,
4, and then
so go ahead and put the balls on the ends.
yes. I'm freaking. You need 4 of these, and then just stick it in, and then you can it will look really nice. But your clay doesn't have to have colors once again.
And you know, you can have 4, you could do it 2-sided. But we'll just kind of give you an idea of what it's going to do. It balances pretty darn good.
Yes. I don't know if you noticed, but I did dark.
Here, grab that bowl, honey. Here, let me set this one on here.
So she's gonna do hers, and
And as you can see, just the balance, and you can get it to spin.
On your finger. And it might be a little sharp, but don't worry.
So that's how you make clay spindles.
Yeah. And it looks out pretty good. You can put this in your room. You can put it anywhere you want.
They're like moons.
You can have it in your birthday party too. I had one at my birthday party.
And they
All right.
look like a moon. Make sure you make spindles with clay balls. It doesn't matter what balls you have, but it doesn't have to look pretty. So make small spindles. Yeah.
All right, girls.
Now it's time to make some. Okay, can we have a sushi?
So glad you could join us. Keep watching. There's lots more.
Young and old alike gathered to watch a restored steam-powered train arrive in Salina on Wednesday, November 20th, 2019. The locomotive chugged into the train station at 400 North 13th Street about 2:40 p.m., 25 minutes behind schedule. The Union Pacific Big Boy number 4014 is touring the American Southwest. The tour was created to celebrate the 150th anniversary of the completion of the Transcontinental Railroad. The Big Boy locomotive was originally retired in 1961 after operating for 20 years and traveling more than 1 million miles. After Union Pacific reacquired the locomotive in 2013, the company began restoring it. The train began its second round of travels in May 2019. For Salina Media Connection, I'm Jason Beats.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 1
Today we're at Wells, Nevada at the Ruby Mountain Ranger District at the first of its kind ribbon cutting ceremony for a pollinator garden. We've taken a thirsty sod grass and converted it to a xeriscape with an array of pollinator friendly plants that are locally adapted to the drought conditions here in the Central Basin and Range ecosystem or ecoregion. 1 in 3 bites of food that we take are pollinated by an animal pollinator, such as the European honeybee and our native bees and other pollinators. Pollinators fit into the web of life. In some cases, they're actually, the food for other animals, and they create through reproduction the berries and fruits and plants that other animals eat. Pollinators are in decline right now. There's been a simultaneous global decline of pollinators, especially the honeybees, the native bumblebees and other native bees, and the monarch butterfly migration is imperiled right now on both the West Coast and the East Coast populations. Pollinator gardens help increase awareness to the public, and it's a great way to outreach to the public and youth and make them aware of the plights of the pollinators. We are also working to practice restoration on a small scale for the types of restoration we'll be doing on landscape levels. We've got an array of plants. What you want is a number of plants that have different colors and shapes and sizes of flowers, and you want them to be biologically active early, middle, and late in the flowering season so that the pollinators have food throughout the growing season. Now the public can do their own pollinator gardens, and they don't have to have the local genetics, but we sure would like to make the seed sources available that are from the Central Basin and Range ecoregion. But you can get involved by planting your own pollinator garden. And there's resources out there on pollinator.org where it'll guide you on what plants benefit bees and butterflies, which ones specifically benefit monarchs, such as the milkweed that we've planted here. And there's tools and techniques on how to plan your garden and how to keep and maintain it. Let's not lose our pollinators. Let's not lose our food and environmental health.
Well, we're well into summer now, Pete. It's July and we have the inner planets in our morning skies. Let's start with Mercury. The planet reaches inferior conjunction on the 1st of July, so it's then in our morning skies straight after. And it's poorly placed for the first half of July, but things improve from the 16th of July onwards.
Yes, they do indeed. It's about magnitude plus 1.4 on the 16th of July. And it rises about an hour before the sun above the northeastern horizon. It reaches greatest western elongation on the 22nd of July, which is quite a good one, actually. It's about 20.1 degrees, so it's a fair separation from the sun. And by the end of the month, it'll be pretty bright, about minus 0.7, rising about an hour and a half before the sun. So that's not too bad at all, is it?
No, that's a good one. If you fancy getting up early in the morning, that'll give you plenty to see. Moving out, we have the planet Venus. That's also in our morning skies. We had a great eastern elongation in the winter and springtime where Venus was really high in the evening sky. It reached inferior conjunction on the 3rd of June and is now in our morning skies. And it really is a beacon in the morning skies. It really is very bright. Magnitude minus 4.3 at the start of July. And if you looked at it with a telescope, you'll see that it's still in its crescent form. It'll be about 18% illuminated and 42 arc seconds across. That's enormous.
That's at the beginning of July, isn't it? Yeah, and at the end of the month, it's rising about 3 hours before sunrise, so that's pretty good as well. And if you look at it with a telescope, then it's about 42% lit and 27 arc seconds across. So it's sort of getting into the fat crescent phase, if you like. That's a good way of describing it. But it's a fantastic planet to look at when you start to see that crescent. That's my favourite part of Venus, I think.
It is. It's a show because most of the cloud features are a lot harder to pick up by then. But there is something about this brilliantly large illuminated crescent side that Venus has. I think it is particularly pretty. Okay, well, let's move out to the planet Mars. Now, Mars has been hovering down low on the horizon. Well, actually, a lot of the planets have been doing that. But Mars in particular is now really starting to improve. We're going to have a great opposition of Mars. It comes to opposition in October, and it'll be very large and quite high in the sky. On the 1st of the month, it's low in the southeastern horizon. It's only around altitude 15 degrees and magnitude minus 0.5
as the sky starts to brighten. Yeah, that's right. It's not been it's sort of positioned itself quite badly, hasn't it, over the last few weeks or so, because it's
deliberately, I think.
what as a prelude to its appearance at the end of the year. I mean,
yes
we've been touting how great Mars is going to appear. And, of course, it's just been getting worse and worse. So I think this is now the time when it's actually starting to turn the tide, and it'll start to get into a much better position and become significantly brighter.
Yes, that's right. So on the 12th of July, Mars will be rising about 1 a.m. and shining magnitude minus 0.7, and it'll be just 3 degrees from a 59% lit waning gibbous moon. So that's a nice little pairing. And the disk size is getting larger now. So at the start of the month, 11 arc seconds across. Even an 8-inch telescope, 6-inch telescopes will start to see some good surface detail on a disk that size.
Yeah, and it grows, doesn't it? So on the 31st of July, it'll be about 14 arc seconds across, which is pretty good, getting good for Mars. And it'll be shining at mag minus 1.1 at that time. So
that really will be quite striking in the sky.
Yeah, it's something which I can remember, actually. I can remember going on a Sky at Night shoot. It wasn't to look at Mars. This was years ago. And Mars was up in the sky, and it was in that sort of state where it was very bright and just shining away. And it literally took my breath away looking at it, because it's just that beautiful colour.
Yes.
In such an intense dot in the sky is quite stunning.
It is, because there's nothing else in the sky like it of that particular colour of brightness, so it just draws your attention immediately. Do you remember how prominent it was from Mars Hill in Flagstaff when we were there a couple of years ago? It was also really striking then.
Yes, when we could see it through the thunderstorms and the clouds.
We got 2 views of it with a telescope on board you once.
OK, well, let's go to the gas giants now. We could probably do these together because we've got Jupiter and Saturn, which are actually quite close to one another in the sky at the moment.
They are indeed. Both low down. Feels like these planets have been low down for decades, but things will improve as the planets, they will continue to get higher in the sky. But for the month of July, they're low down in Sagittarius. Jupiter comes to opposition on the 14th of July, so that's when the best time to observe it is. It's around all night opposition and at its brightest. It's going to be quite low in the sky, but you can get good seeing conditions in the summer. I remember once looking at Jupiter with my 8-inch telescope. It was in July. It had been a hot day, but about 10 in the evening, the seeing stabilised. I got some really good views, so it's best not to write them off just yet.
You've got to be tenacious, haven't you? You've just got to check it every night.
Yes.
And it's, sometimes it's quite surprising because if you're a planetary imager, you sort of tend to look at jet stream forecasts and whatever to try and get the jet stream out of the way. But it's really difficult sometimes to get that absolutely right. And the only way of really checking is to actually go and look yourself and see what's happening.
Which is what you should be doing anyway. It's the proper way to observe.
Oh, here we go. Okay, so it's, Jupiter's shining away at minus 2.6 at opposition. And it's joined, as I mentioned earlier, by Saturn, which is slightly to the east of it. And that also reaches opposition in July, about a week later on the 20th. So that's two planets in rapid opposition. And that's actually quite interesting because opposition is the time when the planet is in the opposite part of the sky to the sun. And when that happens, the distance between Earth and the planet is minimized. So that means the planet looks at its largest to us. Now, that effect is most noticeable with a planet which is naturally relatively close to us, like Mars. With Jupiter looks a bit brighter and a little bit larger through the telescope, but not a significant difference. And Saturn's further out, so you'd think the difference would be even less with that. But there is a big difference there because the rings start to brighten, don't they?
Yes, that's right. There's this wonderful effect called the Seelinger effect or the opposition effect. And a couple of days before Saturn reaches opposition and a couple of days afterwards, the rings really begin to brighten up, and it is strikingly noticeable. So last year, I remember looking at Saturn around the time of opposition, and the B ring, this is the ring between the Saturn's rings can be split into three. The outer one is the A1. The A ring, the inner one is the B ring, and the darker innermost one is C.
Yeah.
The B ring was really, really bright and dazzling, and it's really a striking effect. You can see it in a small telescope, 3 or 4 inch refractor. You'll notice the rings are really quite dazzling at the time of opposition.
Yeah, I have noticed it before, and it's just it is quite stunning, as you say. And you do notice it when you're imaging the planet as well. The rings sort of stand out very, very well. And the reason why that's happening is that the rings are made up effectively of particles as we see it. And those particles, which range in size from tiny up to sort of, I think, about the size of a house, aren't they?
Yeah, big boulders.
And they cast shadows behind them. And when we see the planet away from opposition, those particles cast shadows on the particles behind them, and they hide those particles behind them. But at opposition, the shadows line up behind the particles, so we don't see the effect they make, so that makes the rings appear to brighten up a bit. And it's really something to look out for. So that's a good thing with Saturn.
It is, and we should perhaps just say that if it's cloudy on the night of opposition on the 20th of July, don't worry, because the effect is noticeable about 3 or 4 days before and after, so there's bound to be a chance there you can get to have a look.
I think that's another good point, actually, with opposition with planets anyway, because we're coming up, as we said earlier, to an opposition of Mars in October. And there could be a tendency to imply that the only time to actually observe the planet is on the night of opposition, and that's not true.
No.
It's actually in the weeks and months either side of opposition. That's the best time to pick it up, because you see the differences, and the planets would normally be giving quite a good appearance anyway over that period.
Yes, that's right. So don't just go out and think, oh, opposition's cloudy, no more observing of the planets. You've got weeks before and afterwards where they're just as good. Okay,
it's relentless.
It's relentless. Let's move out to the ice giants now. Uranus and Neptune, they are in the morning sky. Uranus is in Aries and reaches an altitude of 23 degrees. Shining magnitude 5.8, you probably are going to need binoculars to see it. Have you ever seen it with the naked eye, Pete?
Uranus I have, yes, a few times. But it is tricky because it tends to be in a position in the sky where there are lots of other stars around magnitude 6, sort of high fives into magnitude 6, and it's quite easy sometimes to mistake those for Uranus. So you can sort of see the faint objects there.
Yeah.
But it's not always obvious which one is the planet.
Yes.
So you know you've seen it, but you haven't been able to identify it absolutely. And of course, with Neptune, you can't see it with the naked eye anyway. You need binoculars at least to be able to see it because it's magnitude plus 7.8.
Yes,
but
in the constellation of Aquarius at the moment.
Yeah, it's in a slightly better position, actually, slightly to the west. So it's reaching a reasonably high altitude due south in darkness by the end of the month. So it reaches a height of about 29 degrees above the horizon. So this is probably the beginning of Neptune observing season. I mean, neither of these planets are going to give you a huge amount of detail, but there is still stuff to see.
Yes,
with them, isn't
there is. In actual fact, imagers like yourself, Pete, with large telescopes, have produced some striking images of both Uranus and Neptune in the last couple of years, showing all sorts of storms that we didn't know were happening on the surface. And this is because two reasons. Firstly, amateurs now have access to bigger telescopes and very good imaging techniques. And secondly, these planets are higher in the sky now. In fact, Uranus is the best placed planet in the night sky, or will be when it returns to the night sky, given its altitude.
It's quite sad, isn't it? For us in the northern hemisphere, anyway. Okay, well, let's move on to some of the specials which are happening this month. So we're in the second half of noctilucent cloud season. And noctilucent clouds are the highest clouds on the planet. They're about 50 miles up. And what happens is sort of 90 to 120 minutes after sunset low in the northwest, or a similar time before sunrise low in the northeast, you may catch a glimpse of these clouds as they reflect sunlight. Even though it's dark for us on the ground, they reflect sunlight because they're so high up. And they can have this sort of weird, delicate electric blue appearance to themselves. And they're quite eerie to see, actually, if they're there. But there's no guarantee they're going to be there on any particular night. What's incredible about them is that if you do get a good display, you think, wow, it's amazing. Tomorrow night I'm going to go out and I'm going to get some photographs of that. You'll often find you go out and they aren't there at all the following night.
Yes, you have to catch them when they're there. We've had some good displays up here. And I've been quite surprised just by how much detail you could see in the noctilucent clouds. Do you remember the display a couple of years ago, Pete, we had here?
Yes, that's right. I think we got a good one last year as well. This is from Leicester, we should explain. So in a city with a lot of light pollution, they stood out extremely well. And
very dynamic. We see them evolve over time. It was a very bright display, a very, very impressive one.
Yeah, they are quite something. If you catch them, they are quite something. They do sort of draw you in as well. And I should point out that they are often quite low down. And I've had displays when I lived on the south coast. I've been able to see them from there, and I've reported that they're there. And people have said, no, we can't see them further north from me. And they must be able to see them because they're further north. And the reason why they can't see them is because they've got buildings or trees in the way. So they can trick you because they are there, but they're just really, really low down. So bear that in mind.
Okay, and on the 4th, Earth reaches aphelion on the 4th of July. So this is the position where the planet is at the greatest distance from the Sun in the year. Aphelion in 2020 occurs at a very specific time, 12:34 BST, so that's 11:34 UT. and we will be about 152 million kilometres from the sun.
I'll be precise, Paul. It's 152,095,295 kilometres.
All right.
I've measured everyone.
Paced them out, did you?
Well, the sun will actually appear at its smallest apparent diameter at this time. Now, that may now not sound very significant, but being a solar imager, I've got a calcium K set up where the sun normally doesn't fit on the frame of the camera I use with that particular filter. But I can tell you, around aphelion, it does. It's quite tight, but I can get the whole disc in one go. So that's quite useful for me, at least. Okay, so as we get to the opposition of Jupiter, we should also mention some of the events which happen with its 4 Galilean moons.
Yeah, this is lovely. I know that it's not a lot of science in following the Galilean moons, but I do love observing them, and I love observing their shadows. So as the Galilean moons pass across Jupiter, that's what we call a transit, the shadows of these moons are cast onto the cloud belts of Jupiter. And they're normally either the shadow is either it hits the planet first and then the moon transits, or the other way round, the moon transits and then the shadow follows. But at the time of opposition, the shadows and the moons coincide.
Yeah.
And we've got a particularly nice display of this on the 9th of July, where at 01:15, Io and its shadow will be on the central meridian of Jupiter. That's the imaginary line running north and south, and the satellite will appear to be in sync. So you'll see Io as a yellowish dot and a black, almost like a black halo around it, which is the shadow immediately behind. It's quite an eerie sight.
It is. We should point out that's 01:15 UT, so
Yes.
02:15 BST. Yeah, but often the shadows are actually offset above or below the moon because the alignment isn't perfect. The alignment's only perfect when Jupiter is experiencing an equinox, which I believe is coming up next year, isn't it?
Yes, that's right. But when that happens, we also get the mutual phenomenon where the Galilean satellites not only pass in front of Jupiter, but pass in front of each other. And when that happens at opposition, you get their shadows cast onto each other. And that really is a phenomenal sight, I think.
It is quite amazing, actually. I can remember imaging shadows of one moon pass over the surface of another, and you can actually see the shape of the shadow as it passes over the tiny disk of the moon, which is incredible. Okay, well, on the 10th, there's another opportunity to see a moon and its shadow in sync. That'll be the turn of Europa. And Europa and its shadow will both appear centrally on Jupiter's disk at around 02:30 BST, so 01:30 UT. So again, there's two opportunities there if you get clouded out on one of those evenings.
Yes.
What we're talking about the moons, by the way, Paul, on the 11th, Jupiter's going to have an extra moon in the form of magnitude plus 7.7 TYC 6311-253-1, catchy title, and that's a star, and Jupiter will sort of move so that the star is just 1.5 arc minutes from Jupiter's centre. That's about 23:50 BST on the evening of the 11th.
Except it's not really a moon, though, is it?
It's not, but somebody will report it and say there's a new moon.
Do you think? Because it's the Galilean moons are really bright. Almost they show discs in a 8-inch telescope. So it's a faint star, magnitude 7.7.
I think, if you look at it with a small telescope, it'll look quite similar to a moon.
That's true, actually. It will depend on the size of the telescope. Well, there's a nice photo opportunity for you and all of your imaging cohort, Pete, on the 25th. I'm actually going to watch this myself. It's the Callisto transits Jupiter from 22:55 BST, so that's 21:55 UT, and the moon will appear centrally on Jupiter's disk at around 00:45 BST. On the 26th or 23:45 UT on the 25th. The reason this is such a interesting phenomenon is because Callisto is the furthest of the Galilean satellites, and so it takes a lot longer to orbit Jupiter, and so you don't very often get transits of Callisto. In fact, I think I only have 3 or 4 drawings of transits of Callisto, so it's really quite rare, and I'm quite looking forward to it.
Again, that's due to the fact that we're getting close to a Jovian equinox. So, because it normally passes above or below, doesn't it?
It does, that's right. And it is because it's such a dark moon, when it's on the disk of Jupiter, it really is quite dark. In fact, sometimes I've mistaken it for a shadow and then had to check because I thought, what on earth could be casting a shadow that size?
Wow.
And then you check up and find out, no, it's Callisto. So that's going to be quite exciting.
That will be exciting. Okay, well, finally on the 27th, we've got the peak of the Southern Delta Aquarid meteor shower, which reaches a peak on the evening of the 27th with a ZHR of 18 meteors per hour, which isn't particularly high, and the radiant is actually quite low. The moon will be just past first quarter and sets around about midnight on the 27th. So we'll lose it sort of into the evening. So if you see a meteor streaking across the sky, probably in the morning of the 28th, that will be probably a Southern Delta Aquarid. But of course, to belong to that shower, it has to be coming from the shower radiant.
Yes, so that could be a nice one to watch, and maybe we'll see a few meteors from that. Well, let's move out into the stars now, Pete, because as darkness falls, we have the red supergiant Antares, which is low towards the west of south. Antares is a beautiful orange star named the rival of Mars. I don't think it is the rival of Mars, but we'll be able to check that later in the year. Lies north of this vaguely ill-defined constellation of Ophiuchus, the serpent bearer.
Yeah, I mean, Antares is a beautiful star, and Scorpius is a beautiful constellation, but it's cut in half as we see it from the UK, or not half, but the bottom part is truncated by the horizon. But it disappears so quickly as we go past the solstice, which was in June. Antares sort of drifts over to the west as the sky starts to darken. But as you're saying, we've got Ophiuchus, the serpent bearer, and that's a huge area of the sky, often described as looking like an inverted flower pot, although from the southern hemisphere I think they have an asterism in there which is rather macabre. It's called the coffin.
Oh dear.
And it does have that coffin shape. But it's got a number of interesting deep sky objects in there. A load of globulars. There's M9, M10, M12, M14, M19 and M107. How many of those have you seen?
That's a lot. Actually, none.
Oh, right, okay.
There's a lot of globular. There's a lot of globular clusters. Actually, that's not true. I have seen M9 and M10, but they were fleeting views. I've not seen the others, but I have seen M4, which is near to Antares. But as I gather, the constellation of Ophiuchus contains the open cluster IC4665, which I have seen. That's quite an impressive little cluster, I think.
It's lovely. It's just off the northeast shoulder of the serpent bearer, and very close to it, slightly to the east, is a distinctive V-shaped asterism known as Poniatowski's bull.
Right.
And it has a very striking resemblance to the V-shaped cluster called the Hyades in Taurus, the bull, which is visible during autumn and winter, of course. But it is something nice to look out for. It's one of those asterisms, Poniatowski's bull, that is, you sort of pass it over. You may look at that area of the sky quite a lot, but you just don't notice it. But when you actually make the effort to see it, you think, wow, because it is quite a striking V. So you've got to do that this July.
What to look out for?
Ophiuchus, of course, is the serpent bearer, and he is carrying the serpent, strangely enough, which is represented by the constellation of Serpens, the serpent, which is an odd constellation because it's the only one in the sky which is split in two. So you've got Serpens caput, which represents the serpent's head, projects to the west of Ophiuchus, and then you've got Serpens cauda, which represents the tail, zigzags off to the east of the serpent bearer. So it's an interesting constellation, and the western part, Serpens caput, stretches north towards Corona Borealis, the northern crown, which is a distinctive semicircle of stars. But it also, that's heading into that beautiful, very large kite-shaped constellation of Boötes the herdsman, which is marked by the bright orange star Arcturus, of course.
Yeah, it does take up a lot of space in the sky, these constellations. Actually, Russell Haig...
I don't think they can help it.
No, I'm not saying they can, Peter. It's simply an observation. Russell Haig represents Ophiuchus's head, and actually nearby is Russell Getty, Alpha Herculis, which is the head of Hercules the Strongman. So two constellations are actually quite close together. Shows how large they are, really, in the night sky.
Yeah, the Hercules and Boötes and Corona Borealis, you sort of normally associate with the springtime sky. So this is that sort of boundary crossing the two. But it is interesting that you've got Russell Haig, which is the serpent bearer's head, and Russell Getty, which is the strongman's head, but they're very close to each other. But Russell Getty, of course, is at the bottom of Hercules, so that indicates that the constellation is actually upside down as we see it.
Which is a shame, because actually the Keystone asterism does look like the torso, doesn't it?
It's a very, very confusing area of the sky. Okay, well, as summer's getting underway and we're heading into July, we should point out, of course, that the Milky Way is looking particularly wonderful. It'll look wonderful into July, August and September when the moon is out of the way. But it's a glorious sight if you've got dark skies. Now, we don't know whether we're going to be allowed out, obviously, because we're still in lockdown as we're recording this as we go through into July. But if you are, and if you're in a town or city, the best way to see the Milky Way is to get somewhere dark, like out in the countryside. And if you can make out that distinctive asterism, which Patrick Moore could never, ever see. We used to have arguments about it looking like this, but I know it as the teapot, because it looks just like a teapot. Patrick could never see it as a teapot. But the spout marks the direction of the core of the Milky Way. And if you look to where the steam would be rising out of the spout, that's where you've got some wonderful deep sky objects like M8, the Lagoon Nebula, and M20, the Trifid Nebula.
Yes, it's. I do agree. It does look like a teapot. I think it was when you described the globular clusters of steam coming out of the spout that he really decided that there was no such thing, that he couldn't see the teapot.
Enough is enough.
Enough is enough. But it does actually. I think it does look like a teapot, and it is a wonderful area of sky. And this, of course, is where the core, the centre of our galaxy, resides from the Earth's point of view. This is where the Milky Way is at its brightest, and it's a shame, really, because it's low down from the UK skies, and it doesn't look particularly bright. But at southern latitudes, it really is quite a sight.
It's quite spectacular. Okay, well, we'll talk more about that next month. So I think there's plenty to go out and have a look at. Thank you very much, Paul.
Thanks, Pete.
Thanks for tagging along with us. Up next, some more arts and crafts with Ashley Wheeler.
This is the Art Baker show.
We are going to be making flowers out of flour. I mean, a tissue made that's going to be made into a flower. So everybody is going to need a rubber band. We're not going to need it exactly yet. And then we are going to fold it zigzaggy this way, that way, like that.
So is that kind of, hey, Rosalind, I need you to have a seat so we can make a flower. Rosalind? So is that kind of like a zigzag fold?
Yes.
And I noticed you have like 3 layers of tissue there, huh?
Yes.
Does that just make for a...
Yes, if you have different kinds of tissue, then you're going to want more layers than you have. We use this kind of tissue. If you don't have this tissue, then you can stack more tissues. And then everybody's going to need their rubber band once they have it folded and put it in the middle.
You want it pretty tight?
Yes, and you're going to want, you don't want your rubber band spreaded out, because then you'll see the rubber band and it won't look realistic. And then once you get it pretty tight, you're going to want to stretch the sides and then pick one side, and then you're going to need to take out the layers of what you have. But you're going to want your layers pretty spread out so it's not really thick.
Mama, mine doesn't work.
And then
We're doing that on both sides?
yes. And then once you have it all spread out on one side, do the other side. It used to just look like a normal tissue, but now look at it. And then we're gonna finish spreading it out.
And then I think I have an example of some that we have done before.
Yes.
I'm gonna go grab that real quick.
Okay.
Mine doesn't work.
And then we used clay for the holder. And then once you have it done, it looks like it looks like a cheerleader thing. But then you're going
A pom-pom?
yeah, and then you're going to need to take it and then do this. And then look on this side, and then it looks like a pretty rose. And then you're going to need to take another rubber band. You guys can grab another rubber band if you need to. And then you're going to need to wrap it around till it's tight, because you don't want the flower to mix.
And then I found this really nice. It's like an acrylic spray paint, so it's not like regular, you know, as fumey as spray paint, but
And
you
then
just
you can pick what color you want to spray paint. But if you have cloth spray, you can use cloth spray. But you're gonna want it from a far distance, so it's light, like these that we've done earlier.
just give it a little spritz, and
And then you're
that's
good.
pretty.
Yes.
Mama, I don't have one. Mama, I don't have one.
So
I don't have one, Mommy.
It looks
that's how you make flowers out of tissue.
yeah.
Thank you for watching Kids Connection. Make sure to watch it next time.
The City of Salina's convenient drive-through recycling center is open again for business. Staff is there to help you unload bottles, cans, papers, boxes, all the recyclables you're ready to hand off. The Salina Drive-Through Recycling Center, SDRC, open again after the COVID-19 stay-at-home order. Expected budget cuts are creating a few changes in hours and procedures. And look for separate trucks with room for 2 lines, one in the fenced-in area, and the other truck may be parked outside for extra customers. Hours have changed a bit. For now, drive-through recycling is available Wednesday through Friday, 8 a.m. to 4 p.m., and Saturdays, 8 a.m. to noon. The restriction on plastic bags has been removed. You can now use plastic bags for bringing in all your recyclables, and other approved containers for drop-off besides plastic bags are paper bags, cardboard boxes,